Every single day, your feed gets flooded with the exact same lie. Just paste one keyword, click run, and let AI print you thousands of dollars in passive income while you sleep. They make it look effortless. They show you slick dashboards, automated faceless channels racking up millions of views, and GitHub repositories that promise to spin up an entire media empire from a single laptop. But notice how none of these gurus ever show you the actual retention metrics of those videos. Notice how they never show you the underlying codebase or the massive hidden costs required to actually scale these operations. Today, we are stripping away the hype. We are going under the hood of the most popular open-source video automation framework on GitHub right now, MoneyPrinterTurbo. We're going to do a ruthless, engineering-first autopsy on how these systems actually work, why they can run on an absolute potato laptop with only 4 gigabytes of RAM, and the fatal architectural flaw that makes 99% of default AI-generated videos completely unwatchable. If you are trying to build a serious digital media operation, this is the reality check you've been waiting for. Let's look at the assembly line. To understand why these automation tools are both incredibly clever and deeply flawed, you have to understand what they actually are. MoneyPrinterTurbo doesn't contain some magical, proprietary, video-generating AI model. It is not Sora, and it is not Runway. It is an orchestration layer. It's a traffic cop written in Python that coordinates a bunch of completely separate cloud APIs and local media tools into a single automated assembly line. Here is the exact anatomy of a one-click automated video pipeline. First, you give the system a single topic or keyword. The framework takes that keyword and flings it over a network request to a cloud large language model, usually an OpenAI-compatible endpoint like GPT-4o or Claude. The LLM writes the raw narration script. Second, that raw script is split into 2 parallel paths. Path A sends the text to a text-to-speech engine, like Edge TTS or Azure Cognitive Voices, to render the audio file. Path B pushes the script through a keyword extraction algorithm to figure out what the video should look like. Third, those extracted keywords are programmatically fired off to stock media databases like Pexels or Pixabay via API keys to download short B-roll clips. Finally, the local machine takes the audio file, the stock video clips, and uses a local subtitle generator like Whisper to align the timestamps. It hands all of these raw components over to FFmpeg, the absolute workhorse of command-line video editing, to stitch, render, and burn the final MP4 file. This entire architecture explains the massive paradox that confuses so many beginners. How does this software run flawlessly on a basic machine with only 4 gigabytes of RAM and no dedicated graphics card? The answer is simple. Your computer isn't doing any heavy lifting. The computationally intensive AI inference, the deep learning, the language generation, the voice synthesis, is all being subsidized by massive cloud data centers. Your local machine is just a digital courier, downloading flat .mp3 mon and .mp4 files and using your CPU to glue them together. If this pipeline processed everything sequentially, meaning it waited for the script to finish, then waited for the full voiceover to render, then waited for every single video clip to download one by one, it would take 20 minutes just to generate a 60-second video. The smartest engineering choice in this framework is pipeline parallelization. The software leverages asynchronous programming to overlap I/O latency. While the system is stuck waiting on a sluggish response from a stock video API endpoint, it doesn't freeze the entire machine. It concurrently fires up the voice synthesis engine, starts calculating subtitle timestamps, and pre-stages the rendering directory. By overlapping these operations, the system cuts total wall clock execution time down to a fraction of traditional rendering pipelines. It's elegant software engineering, but this is exactly where the engineering efficiency collides violently with content quality. Let's talk about why 99% of fully automated default AI channels fail to get monetization, drop to 0 views after a week, and completely destroy audience retention. It comes down to a fundamental architectural bottleneck called semantic drift. Remember how the pipeline splits the script into 2 separate paths. The audio goes one way, and the keyword extraction goes the other. Because these 2 paths never communicate with each other mid-flight, the system has absolutely zero contextual awareness of how text correlates to visuals. Let me give you a real-world example. Say your AI scriptwriter generates an inspiring line about personal finance. When you are trying to scale a massive mountain of debt, every dollar counts. The keyword extractor looks at that sentence. It doesn't understand metaphor, nuance, or human emotion. It just extracts the highest weighted noun, mountain. It plugs mountain into the Pexel stock footage, API, pulls the first high-definition clip available, and downloads a breathtaking, serene drone shot of the Swiss Alps. So now your viewer is listening to an intense talk about credit card interest while staring at a peaceful, snowy mountain peak. The audio and the visuals are in a state of total semantic divorce. Humans are incredibly sensitive to this. The second a viewer's brain registers that the visual B-roll doesn't genuinely match the emotional or intellectual context of the spoken words, they feel the cognitive dissonance, they realize it's a low-effort automated asset dump, and they swipe away. The second major lie we need to dismantle is the 10-second setup myth. If you look at the documentation for these open-source tools, it looks incredibly straightforward, but for a non-technical creator, the barrier to entry is a steep brick wall. To actually get this running in a stable environment, you aren't just double-clicking an application icon. You are installing Docker Desktop, managing container virtualization, cloning repositories via the terminal, and manually configuring a config.c. Have to hunt down API keys from multiple third-party providers, map network ports, and handle dependency conflicts. For a seasoned developer, it's a 20-minute task. For a beginner, it's an entire afternoon of troubleshooting cryptic error logs. And then there's the financial reality. Open source means the code is free to inspect and modify. It does not mean the system is free to run at scale. When you start pushing high volumes through an automated engine, you hit three distinct operational cost vectors that the gurus never mention. First, you have LLM token fees. If you are utilizing deep reasoning models to write your scripts, those compute costs scale rapidly with every single prompt and iteration. Second, you have premium text-to-speech subscriptions. The free open-source voice models sound distinctively robotic. If you want hyper-realistic, human-like narration that actually holds a viewer's attention, you are going to pay monthly subscription fees for high-tier API access. Third, you have stock media tier limits. Free API keys will aggressively throttle your download limits the moment you try to scale to dozens of videos a day, forcing you straight into paid developer accounts. Automation drastically reduces your manual labor hours, but it does not eliminate your marginal operating costs. So, what is the ultimate verdict on frameworks like MoneyPrinterTurbo? If you evaluate this strictly as a piece of open-source automation engineering, it is easily a 9.5 out of 10. The architecture is clean, the parallelization is smart, and the decoupling of compute via cloud APIs is incredibly pragmatic. But if you evaluate this based on the passive income promises made by internet gurus, expecting it to autonomously generate viral content that builds a sustainable business while you sleep, it is a 3 out of 10. If you want to build a genuine, high-leverage digital media engine in the agentic era, stop treating this software as a finished product. Treat it as a baseline infrastructure. The true competitive advantage doesn't come from hitting run on the default configuration. Everyone has access to the default configuration. The advantage comes from hijacking the pipeline and injecting your own proprietary quality loops. You win by swapping out generic prompts for advanced, programmatic prompt matrices that enforce hyper-specific narrative styles. You win by abandoning free robotic voice models and integrating custom fine-tuned voice clones. And most importantly, you win by introducing a human-in-the-loop workflow, using the automation engine to instantly spin up a rough, assembled first draft, and then letting a human editor spend 10 minutes fixing the semantic drift, swapping out mismatched B-roll, and adding actual creative intent. Technology can automate the assembly line of production, but it cannot automate originality, culture, or audience trust. Use the tools to eliminate the boring work, but never rely on them to do the thinking for you.